Illustrative Math, Algebra 2, Unit 5, Lesson 5 is called Some Functions Have Symmetry. So I put a little picture here of a regular pentagon, and this would be an example of a line of symmetry because well, if you reflect the left side across the right, it'll map onto itself. Now, obviously, there's other lines of symmetry on this figure. There's one right there. There's one right there. There's one right there. Let's see, here's the last one. So there's actually like 5 lines of symmetry on this pentagon. All right, so our goal, I can identify odd and even functions from their graphs, and I understand the definition of odd and even functions. Okay, so you might want to pause the video and write this down. An even function, this is what's important here. You need to make sure that you have this written down right here. Draw a picture here. It's symmetric. An even function is symmetric about the y-axis. So if I fold this graph on the y-axis, it's going to match up. It's going to map. The left side will map onto the right side. It's kind of like, when you make a heart, a Valentine heart, you map. You draw half of it and you fold the paper, and then you cut it out and you have the other half. Okay, kind of the same thing with y-axis symmetry. Another thing to know here, even functions, opposite x coordinates have the same y coordinates. So that means, like, if my point is, f of 3 equals 4, that means, that's function notation, but that just means 3, 4 is a point. Then f of negative 3 will also be 4. So, like, negative 3 would also have a y coordinate of 4. Okay, so you can kind of tell here, this is x, this is negative x. They both have the same y coordinate. All right, I don't really like this definition here for my odd function, so I'm going to change it. I'm going to say f of x equals, I'm sorry, I had that wrong. F of negative x equals negative f of x. Now what they had was they had here f of x equals negative f of negative x. It ends up being the same thing. If I divide by negative 1 here, those cancel. And then when I divide by negative 1, it's kind of the same as multiplying by negative 1, so they just put it in the front. And negative 1, so instead of negative 1, they just make it like a negative sign. So it ends up being what I had, like that. It's the same thing. It's just algebra moves it around. This is the way I've always done it. To me, this is the way my brain works a little bit better, and I can explain it a little bit better. So I would write down that definition. But nonetheless, they're still the same. They're the same thing. That's just the way that it says. Okay, so a couple things here with odd functions. An odd function is a reflection across the x and y axes. So, like, to get here, I have to reflect across x and then y. Okay. Now they actually call that origin symmetry. Okay. I'll write it down here. This is called origin symmetry. That's when you reflect across both axes. Okay, so it almost looks like you're diagonally reflecting it. Okay, but really you reflect across x and then y. Or I guess you could go y and then x. It should be the same either way. You could also think of it as a 180-degree rotation about the origin. So if I had my graph here, right here, if I rotate that thing 180 degrees around the origin, now my program won't let me do it around the origin, so I have to like rotate and then translate. But if I could have done it, I would have rotated it right there. I would have centered it right at the origin right there. All right, so there it is. Odd functions. Opposite x coordinate have opposite y coordinates. So that's why I kind of did it like this, the opposite x's and then opposite y's. So, like, if I have f of 3 equals 6. I don't know. I'm just making this up. Then f of negative 3 is going to equal negative 6. So opposite x's have opposite y's, okay? And again, this just means 3, 6 is a point. If you prefer the xy notation versus the function notation, and negative 3, negative 6 is a point, okay? But you should be proficient with that notation there with the function. Okay, the table shows Claire's elevation on a Ferris wheel at different times t. Claire got on the ride 80 seconds ago. Right now, at time 0 seconds, she's at the top of the ride. So right here is the top of the ride at 0. So we kind of know here it's 212 feet when she's up here. 80 seconds ago, she got on the ride right here. This is at 0. Okay, so think of this as being like your x-axis down here at the bottom. So halfway here, 106. Okay, so this is probably right here at 106. So let's see here. It takes 40 seconds to get here because it was negative 80. So right now she's at the top at time 0. But as I go back, halfway would be 106. So that was at negative 40. And then down at the bottom at negative 80 is at 0. Okay. So the other times would be kind of like right here. That would be the height. Let's see right here. That would be 30. No, wait. That would be 181. Be the height. And that's the vertical height. And then right here would be kind of like halfway in between here. This would be at 31. Okay. And then you keep on going. So obviously 20 seconds back, I was at 181. So 20 seconds further, I'm going to kind of have the same height. If you look here, they're the same y coordinate. Okay, they're like totally exactly the same height. All right, down to the x-axis right here. Okay, they're the same height. Oops, what did I do? All right. Anyways, so yeah, so I'm going to fill that in here on the table here. So this was 181. And then at 40 seconds, so it took 40 seconds to get from here to the top. It's going to take 40 seconds to get right here. So this is at 106. So 40 seconds from there is at 106. And then another 20 seconds would be right here at 31, because you have the same height, your same height off the ground. And then another 80, you're back down here at 0. Okay. So there's my table. So you kind of keep repeating. Okay. So if I were to do another 80 seconds to get to the top, I would kind of just follow the same order. I go 31, 106, 180, 212. All right. So next, so if you were in class, your teacher would give you a set of cards that show graphs. We're going to do this card sort into 2 categories of your choosing. Be prepared to explain the meaning. All right, so here's all my cards. Take a good look at them. I guess since we just did y-axis symmetry and origin symmetry, I guess I could say even and odd. So let's do it. Let's see here. Let me move this here. So I'm going to make one here. This is going to be odd. And this is going to be even. So odd is origin symmetry. So x-axis and y-axis reflection. And this is going to be y-axis symmetry for my evens. All right. So hopefully they all have some symmetry. I don't know. This looks like y-axis, y-axis. This is origin because you reflect across x and then y. So I'm just looking at like this point here. I go across the x-axis to get here, and then the y-axis, and I get there. So this is a y-axis reflection. This is origin symmetry, again, because pick any point, reflect across the x-axis. I get up here to 4, and then reflect across the y-axis. Boom, it gets me right there. This is going to be y-axis. This is origin, and that's origin as well. Okay, so that's good category. Did it say to do two different ones? Nope, just two categories. So obviously that makes sense with what we just did, okay? So let me move this over a little bit here so I got a little more room to work with. Oh, you know what? I guess I don't need to do that because my next slide, I have the tables on them. Okay, I'll just do that. So match each table of coordinate pairs with one of the graphs from earlier. Okay, so I need to match all these tables. Yikes. Okay, so let's do the horizontal line first. So all the y's are 2. So let's find that one. That goes right there. You see how all the y's are 2? Okay, and you can double check some of these points like -7, 2 is right there. 4, 2 would be right there. Okay, so there's that one. All right, let's see here. The only one right here that goes through 4, 0 or 0, 4 is this graph because none of the other ones go through that point. So I'm going to find one that has 0, 4. So 0, 4 is, oh, of course, some of them don't have 0 on there. Okay. Well, let's go stay on this one. This one has -4, 0, and 4, 0. So it could be this one, this -4, 0, 4, 0 could be this one. So let's find some other points. Maybe, let's see here. This is -2, -4. So -2 is up here at 3. So it's not that one. -2 is at 3. 2 is at 3. This one looks pretty good. 6 is at negative. Yeah, I think that's the one right here. Okay, so I'm going to put that right there with that. All right, let's find another one here. 2, 4. Any of these have 2, 4? Here's a 2, 4. Let's check this one. See if this one matches. I'm going to check the points. So 2, 4 is good right there. -2 is at -4. 5 is at 1. -5 is at -1. Looks pretty good. Okay, so there we go. We got that one. All right, so let's see if we can find this one here. Looks like that one might be a hard one. Let's go to this card F. So 2 is at -4. Is there a 2, -4? Here, this one. Let's double check. 2 is at -4. That looks good. -2 is at -4. That looks good. -1, yeah, that looks pretty good. -1.25. -4, yep, there we go. So there's that one. This one here, 2 is at a little bit over 4. How about this one, 3, 0? Any of these have 3, 0? No. 5, 0 right there, x-intercept. 5, 0, here we go. Maybe it's this one. So I'm checking the points here. 5, 0 looks good. -5, 0 looks good. Let's see here. 1, 4. That looks pretty good. -1, -4. Yeah, that one looks good. So I got 3 more here. So let's see here. Let's take this one up here. Let's see here. I don't know. -2, -1. That looks good. -3 is at -3 something. That looks pretty good. Yeah, this one looks like it matches. And then the last two. Let's try this and see if this one works. So -6 is at -3. That looks good. 6 is at -3. That looks good. So I think that one's probably safe to say, and then that one's probably going to go there. Okay. So describe something you notice about the coordinate pairs of even functions. So let's go to my even ones. So even are my y-axis or my y-axis symmetry. So these are even. These are even. That's odd. This is even. So I kind of already ruined the surprise. I told you that opposite x's, so opposite x's have the same y values. So you see there, and then opposite x's. So those are opposite. Those are the same. Opposite x's, same y coordinate. Now let's try another one. I'm not going to do every one, but you can kind of pause the video and look at them yourself. Opposite x's. So I got 4 and -4, same y value. Opposite x's, same y value. Opposite x's, same y value. So for number 2, that's just going to be what we talked about before, where we said opposite. You know what? Have opposite. I'm sorry, have the same y value. Sorry. Okay. Odd functions are going to be, it doesn't say to do anything about odd functions, but we'll go ahead and show you here. So all my odd functions here, this one's odd, this one's odd, this one's odd because it's origin symmetry. So opposite x's have opposite y's. So here, those are opposite x's. Notice the signs, they're opposite there, okay? Same thing here, opposite x's, opposite y's. -2, +2, -1, +1. So they're opposite. Let's go to another odd function. Opposite x's, 5 and -5. Opposite y's. Now that's a little tricky because they're both 0, but -0 and 0 is the same. -4 and 4, 5.25, -5.25. Same thing here, -1 and 1. Those are opposite y's. So you kind of see it there in the graph. All right, using language of inputs and outputs, what's true about even functions? We've already said it. We've said opposite inputs, okay, instead of x's or y's, have the same outputs. Okay, or in other words, you could say, I want to use function notation, f of -x is going to equal f of x. So x's are opposites, but the sign on the outside of the whole function is the same. What's true about odd functions? So odd functions, we've already said it again. Opposite inputs have opposite outputs. Okay, so if I want to write that in function notation, that would be like this: f of -f of x equals f of -x. The inputs are opposite, the outputs are opposite. If a function f is even and f of 3 equals 7, what's something else you know about it? So we know that it has y-axis symmetry, of course. And we know that f of -3, the opposite of the input, will have the same input. If a function g is odd and g of 5 equals -1, what's something else you know? We know that we have origin symmetry. Again, remember, origin symmetry is reflection across both axes. And then we know that we're going to have opposite x, so g of -5 is going to equal opposite y. Okay. All right, if f is an even function and f of 3 equals 6 and f of 4 equals -10, tell me 3 things about f. All right, we already said this a bunch of times, but it has y-axis symmetry. And f of -3 will also equal 6. F of -4 will also equal -10. Odd, obviously it has origin symmetry. G of -3 will equal +1. Opposite x is opposite y's. G of -5 will equal -12. So there's my three things. All right, our goal, I can identify odd and even functions from their graphs. Did that in the card sort. I understand the definition of odd and even functions. Okay, hopefully you wrote those down earlier. Last thing is the cool down. What is the value of a if h is an even function? So if this is an even function, so 4 and -4, we got those right here. So if it's even, you're going to have the same y coordinates. So this would also be 1/2. So what's the value of a if it's odd? So opposite x's will have opposite y's. So that would be -1/2. Okay. All right. Thanks for watching. I hope you enjoyed this video, and we'll see you next time.